This is Numbers in Chemistry by gdehlert. Qualitative numbers are given. Here's some observations that are qualitative numbers. The building is really tall. I live really far away. This is things that aren't using specific set distances, but not numbers. Quantitative, however, does use numbers. For example, the river is 31.5 meters deep, and the cheese costs $4.25 per pound. Here's some different units, metric base units, and prefixes for the metric base units that are here. It's pretty self-explanatory, just different units of measure. Scientific notation can be used to make very large or very small numbers easier to handle. For example, 45 with 15 zeros after it can also be written as 4.5 times 10 to the 16th. The 16 tells you how many decimal places are to the right of the 4 and the rest of the number. Whoops. Another example is for a very small number, it's 0.0014 zeros. 378 can be written as 3.78 times 10 to the negative 15th. The negative 15 tells you how many decimal places are to the left of the 3 and the end of the number. Multiplying using scientific notation. When you multiply the two numbers in scientific notation, you simply add the exponents. For example, 4.5 times 10 to the 12th times 3.2 times 10 to the 36th is simply 4.5 times 3.2, and then you multiply that number by 10 to the 12 plus 16, which in this case is 14.4 times 10 to the 48th. When you divide, you subtract the denominator's exponent from the numerator's exponent, and that is all you do. When you add, you have to get the same exponent in both numbers. So in this case, I made 4.2 times 10 to the 6th, 42 times 10 to the 5th, so that both numbers would have a 10 to the 5th. And then you add the numbers, and subtracting numbers is the same thing, but instead of adding the numbers, you subtract the numbers, like this. And this is the end of my presentation.